Hi students, here let's start our class regarding the electrochemical conductance only. We're discussing. Students, let's start our discussion today. Today class depend upon today class topic is conductance in electrolyte solutions. So up to discuss about the conductance which carries by the metals only, other electrons we discuss here. Right now we are discussing about the conductance is carried by the electrolyte solutions only. Do you know very well, when you remember, if you are just taking the one small amount of the glass, two electrodes we place and we connect to the battery, some chemical reactions happen. If you can take the one small LED light when you place in solution, it started glowing only. That glow will be depend upon the amount of concentration only. So regarding those concentration terms, factors affecting conductance we are discussing in this chapter. That is very important. Let's have discussion about the look in this terminology. We have to remember this important terminology. Okay, conductance. What is conductance here? The ability of an object to allow the flow of electrons. Once again I am repeating here, the ability of an object to allow the flow of electrons. Look at the graphite is good conductor of electricity only. What happens? The graphite is allow the electrons are pass through it only. Look at this call here conductivity. Conductance, conductance. Difference is there, no? If you want to measure the conductance of fixed distance, look at the distance fixed only. If fixed area want to measure conductance of this solution alone, that's known as conductivity. Conductance represented by the G, capital G. Conductor represented by the kappa, capital K. Okay. Next one is resistance. Sorry, resistance. What is resistance here? The ability of an object to resist the flow of electrons is known as resistivity. Okay, the ability of an object here. Okay, resistance, general resistance, the ability of an object to resist the flow of electrons. Suppose if you place your one plastic wire, is the electrons will not be flow, the light will not be glow. Okay, next one, what is the resistivity? If you want to measure the resistance of specific length, if you suppose if you take this is the distance of the one plastic wire from here to here, I want to measure the resistance fixed area and is called resistivity. Clear? Look, I want to once again I'm saying conductance with the ability of an object to flow of electrons only. Okay, conductivity. If you want to measure conductance fixed length only is called conductivity only. Resistance and electrical resistivity only. So next one is that here electrical resistance R is equal to resistance is equal to R is equal to is depend upon the length and area of cross section. This is the area of cross section only. So R proportional to length by area cross sections. What is units are there now here? Ohm. General resistance but ohm only. According to physics you studied. SI units are there now kg meter square, Simon cube area square only. R nothing but here R nothing but resistance. L nothing but length. A nothing but area of cross section. This is the area of cross section. More length is there, more resistance is there. More area is there, less resistance will be there. Clear? When you go for next slide is there, now you'll get very clear. R proportional to L by A. I want to remove the proportionality constant. I use some other constant. Is called that constant is called rho. Rho nothing but a specific resistance or resistivity. Rho is called rho, resistivity or specific resistance. It's very important. Resistance, specific resistance, length, area of cross section. So next one is the here. Look at the here resistance here. Specific resistance units are given here. So what units are there now? Ohm meter square. Ohm meter. Okay, ohm centimeters only. R is equal to resistance is equal to specific resistance into L by A. 1 ohm is equal to 100 centimeters. 100 ohm centimeters. Meters 100 centimeters. No difference is there. Centimeters means 0.01 meters only. Clear? So we'll go for next one is there here. We'll go for the look at the. If you want to take the resistivity or specific resistance, rho is equal to, I want to calculate rho value. Whatever maybe you take the rho is equal to RA by L. Clear? Rho is equal to RA by L only. Look at the students here, don't be confused, just consider I want to calculate rho is equal to, look at the what is there here? A, clear? A R by L only. A R by L only. L only. So here, look at the R is equal to, suppose I'm taking the length and area, say 1 centimeter is 1 centimeter, 1 centimeter square. So what happens, you look at the resistance and specific resistance are both are equal only. So resistivity is defined as the resistance of a substances when it is 1 meter length and area cross section is 1 centimeter square. Okay, area of cross section is 1 centimeter square. So next one is there no conductance resistance opposite news no conductance only. Suppose I'm just taking the resistance only. Suppose I'm taking the resistance. Okay, R is equal to conductance only. R is equal to inverse proportional to conductance 1 by C. Okay, no? Conductance also represented as G only, 1 by C only. R also look at the conductance. R is equal to 1 by R is equal to G. 1 by R is equal to G only. Okay, suppose you know very well resistance units are then ohm only, no? Resistance ohm only, no? Here ohm only. Conductance units are there, no? Ohm universal. Conductance units are ohm universe only. Look at here, they mention SI units are then Siemens, they will take Siemens only. Look at here, look at the Siemens are ohm inverse here, they will take only ohm inverse and mho. So next one is that here sorry, conductance G is equal to 1 by R. Resistance is there, no? R is equal to rho into L by A. Already discussed here. Conductance G is equal to, look at the 1 by, in the place of the 1 by R we mention is rho. Clear is there, no? 1 by R into A by L. Clear. Next one is that here, look at the go for next one is there, no? Conductivity. The reciprocal of resistance is known as conductivity only. What is conductivity here? If you want measure resistance, a fixed length is there, no? If you want measure conductivity, fixed area. This is kappa. This is called conductivity, specific conductivity we can call as it. Okay, no? 1 by rho only. So G is equal to 1 by rho is in this place 1 by rho you mention is kappa into A by L. Kappa into A by L only. So next one is that here, look at the G is equal to 1 K in the place of 1 by rho, 1 by resistance here rho, you can mention kappa into A by L only. Clear is there, no? So next one is that here kappa is equal to, look at the very important even for a problematic is very important. So look, kappa is equal to specific conductivity, kappa is equal to G into L by A. L by A is called as a cell constant. L by A is called as cell constant. You can also represent by the G star. G star nothing but L by A. Clear? Kappa is equal to, you know very well, kappa is equal to G into G star. Kappa is equal to G into G star. G into G star only. Star only. Clear? This one you have to remember. Sorry. The conductivity is defined as the conductance of a material when it is 1 meter long and has cross section is there, 1 square meter is there. Clear is there, no? That is one nothing but conductance only. So remember students, the next one point I'm taking here. Conductance specific kappa is equal to G is equal to conductance is equal to specific conductance into A by L. Clear, no? Already discussed units are there. 1 Simon centimeter inverse, 100 Simon meters inverse only. Units are on already, you know very well, units is there, no? Look at we want to measure the conductance of various materials are there. So I want to measure. I will just calculate value and no need to remember. Just imagine, look at here. Just sodium, I'm just taking the conductance, how much value is there, 2.1. Copper is 5.9. Silver is 6.2. Gold is 4.2. Look at from this data we get very clearly silver is best conductor. Clear? Silver is the best conductor when compared with copper. When you say best conductor means resistance is very less. Got clear, no? So graphite value is 1 only. When you go for the here glass is then the value is minus 10 to the power of minus 16. Minus 16 means is a bad conductor. It doesn't allow flow of electricity only. So it acting as an insulator. Teflon also they mentioned 10 to the power of minus 8. That's the reason why Teflon is used in the electrical wires. Clear is there, no? Suppose I'm taking pure water, the value is going to pure water is bad conductor of electricity only. The value they have given. Look at the 1 molar HCl they given 3.9. Look at the potassium chloride is look at 0.14. Next one is the NaCl is 0.12. Look at the semiconductors are there, no? Copper oxide 1 10 to the power minus 7, silicon 1.5 10 to the power minus 2, germanium nothing but 2 is there. These are the calculated value of the different materials and their conductance. Look at specific conductance only. Clear? Whatever the value you calculate, you take the fixed distance only. Clear? When you go for next slide, you will get here. Look at the conductivity is kappa. The conductivity is kappa depend upon the magnitude of the conductivity, depend upon the nature of the materials, temperature, pressure. This is very important. Temperature increases, ion mobility increases, conductivity increases. Nature of material already we discussed in the previous section is there, no? General silver is best conductor when compared with the iron, gold, platinum only. Pressure. More pressure is there for gases only, more pressure is there, no, its conductivity also dependent increases only. Next one is the materials are based on the specific conductivity. Materials classified into the conductors, insulators, semiconductors only. Let's have discussion about conductors only. You know very well, these are the copper, silver, aluminum. They are conduct electricity. They are used as the electrical wires only. Next one is some other than metals also act as conductors. Graphite, carbon black, and here some polymers of they act as the best conductors only. So next one is insulators. Is glass is insulator. Look at here, just consider some ceramic insulators also is there. Look at in the electrical wire, some ceramic insulators also. They act as a insulators only. Next one is semiconductors. Certain materials we cannot call as conductors, we cannot call as insulators. They will carry a partial percent only. Silicon. Okay, silicon is there. Silicon is doped with some other materials are there. Germanium, arsenic also act as a semiconductors. We are using the electrical chips. Okay, superconductor. What is superconductivity? Suppose any person have some special characters called superpower. Here also certain materials are there. No, they have conduct more amount of electricity is called superconductors only. Superconductors means resistance value 0. Infinite conductance K is infinity. And look at how much amount of, for suppose we pass is there. No, I want one small example. If temperature increases, conductivity of a metals decreases. Clear? Why metals decreases is there? No, because of temperature increases, the ions are move very fastly in aqueous solution. But if you take the metallic rods is there, no, the kernels, nucleus is there, no, move vibrate. Nucleus vibrate up in there, it disturb the flow of electrons. Clear? This point very important. Next, coming to the other some metals is superconductors. Examples they have given: ytterbium, barium, copper oxide. These are superconductors they will use here. Next one is then zinc metal, aluminum metals. They are mentioned types of metals where temperature also they mentioned based on temperature how they will be conductance only. So conductivity electrolyte is very important. How electrolytes are conduct electricity. Look at very well electrolyte conductivity is depend upon the electric current flow by the momentum of ions. Ions move carries electricity. Ions undergo oxidation reduction near to the electrodes. Transfer of matter will take place. Either look at deposition and some gas evolution, everything will take place in the electrolyte conductance. It follows the Ohm's law. Look at we are discussing about the Ohm's law, resistance, temperature factors, Faraday's law. Already discussed here. We will discuss right now only. Clear? Ohm's law only we will discuss here. Next one is coming to the here. Look at here. When I say the material as a conductor or a bad conductor is there. Look at here. Some battery is there. Positive terminal, negative terminal. Here to connect with the one light is there. When the switch, when switch on the light, what happens there? Here, electrical light will be glow. Clear? No confusions. So let's do here. Next one is factors affecting the metallic conductors. Metallic depend upon the nature of the material and structure of the materials. Already we discussed about silver is best conductor. Number of valence electrons. So if we take the some other one is just consider more number of valence electrons, more conductivity will be there. Temperature. Temperature increases, metallic conductors decreases, ionic conductance increases only. Clear? So next one is look at we are discussing about the conductance. This is very important. Students are very clearly observe the entire discussion depend upon this cell only. If you want measure the conductance of this volume of the solution, length between two electrodes are fixed. The size of electrodes are fixed. Area of cross section means if you break the electrode, how much area it is, this is fixed only. Clear? So we want measure the conductance of the, if I take NaCl, I want measure, KCl, I want measure, some other material I want measure. If I want measure conductance of the strong electrolyte, weak electrolyte, and in the case of concentration terms, everything we discuss right now. Clear? Conductance in the look at I mentioned is different red color dots are there, some green color, whatever we take here, it's different ions are produced whenever dissolve in the water. They act as conductors. If you are not decomposing in the water, they never carry electricity, they act as bad conductors only. We discussed how much extent will be dissociated, how much conductance will be carried out only. So look at here, some important terminology is there now here, conductance of the. If I suppose if I added water here, if I added some acid here, it acts as a best conductor only. No? pH value only. If you add acid conductor, base conductor, salt conductor, clear is there no? So in order substance, generally I'm taking here the pH value is given. So conductance of aqueous solution. You want to measure the conductance of aqueous solution. Look at here, it's depend upon the nature of the electrolyte, either strong electrolyte, weak electrolyte, non-electrolyte. Size of ion, more size of ion, less conductance. Less size of ion, more conductions. Solvation only. Less size of ion, look at the less size of ion is there, no more solvation energy, less conductance. Less solvation energy, more conductance only. More concentration is there here. Whenever more concentration is there, molar conductivity, specific conductance will be increases. Temperature, when temperature increases only, conductance value increases for the electrolyte only, not for the metals. So look at it, I want to measure the conductance is in this solution. If I take the NaCl here, KCl, potassium sulfate, this area length is fixed. A length between two electrodes are fixed. The area of cross section also fixed only. Clear? The volume also fixed. If you take the some electrolyte, if you want to go for concentration, the molarity also possible, normality also possible. Otherwise, take the weak electrolyte, strong electrolyte. This length are fixed. That called cell constant is called G star. They will take. If you want to measure the electrolyte conductance in the fixed area is there, we are going for the conductance only. So look at here, the conductance we will measure. Look at G star, nothing but length by area of cross section only. Okay, units for G star nothing but centimeter square only, no. Centimeter length is centimeter, area centimeter square, units are centimeter inverse only. Direct measurement of the length and the area of cross section is difficult only. That's one that taking fixed value already. So G star is equal to L by A, resistance R is equal to rho into L by A. Rho 1 by, look at the rho is equal to 1 by, we mention 1 by kappa only, no. 1 by kappa they mention. Okay. Look at here, they mention about change the concentration, how conductance will be various only. 1 molar concentration, this conductance. 0.1 molar concentration, this conductance. This is concentration, this is conductance. Whenever concentration decreases, conductance will decrease. This will only depend upon specific conductance only, not general conductance only. Okay, molar concentration already they mentioned is there. So look at that, I want to measure the conductance is there, no. Instead of measuring conductance, I want to measure resistance. If I know the resistance value, I can easily find the conductance only. So this is called Wheatstone bridge we discuss in physics only. Whenever these four resistance value is correct, no flow of electrons will be takes place from this peak parameters. Here oscillator is there, O is oscillator. What happens when our resistance value is variable, the electron will be flow from this area. Suppose if I know this resistance value, this resistance value, if I connect with the cell with salt bridge only, what happens there? Here connected to salt bridge, I can easily measure how much amount of conductance will be there. Suppose if I'm taking here, if I take the, look at what I'm taking one cell is, I'm taking one cell. In this cell is there now, I'm placed one electrolyte is there. Here I'm placed the electrolyte is there. Some salt bridge is there. What happens there? If I connected here, I want to measure the resistance also possible only. I can easily measure the resistance only. Look at it, the wire will not be connected. I just made like that. What happened there? If suppose if I where is this fixed, this both are fixed only. This both are fixed only. Okay. No? If I change one is the base on this one, I can easily find the resistance of this one only. No, that's nothing but Wheatstone bridge only. So if you calculate the, look at the R2 value, they will change. They will go R2 is equal to R1 by R4 and by R3. You can calculate resistance. Based on resistance, you can say how much amount of conductance also is there or not. So here, look at the measurement of conductance only. Various devices they will use to measure the conductance only. These are devices which use the measure the conductance only. We will study very well in the physics. So you know where cell constant is equal to length by area. Okay, cell constant. Cell constant, but use R into kappa, resistance into kappa also. R2 is equal to R1, R4 by R3. K nothing but cell constant. Look at the specific conductance kappa is equal to cell constant by resistance. It's a very, very important formula. Kappa is equal to G star by L. One cell constant and one resistivity are known. Then you can find the value of easily. So based on this one only, your application is very, very important. Write down the formulas in your notes to use for the next problem to solve the problems. So molar conductance. Up to discuss about the conductance on the electrolyte on that one, I never discuss about how much amount of concentration is there. If you use the concentration term as the molarity, normality, I never discuss. Right now I'm going to discuss about the molar conductance. What is molar conductance only? If I take the 1 mole of electrolyte, if I take the 1 mole of electrolyte in the solution, okay, how much amount of conductor will be possible? If I take 1 molar of electrolyte here, how much amount of conductance is possible? Molar conductance only. If I take strong electrolyte, how it's possible? Weak electrolyte, how it's possible? If I take the some salts, how it's possible? Discuss in the concentration terms only. So students, the molar conductance kappa by the concentration. K nothing but conductivity, specific conductivity, C nothing but concentration. Molar conductance is equal to kappa by C. C nothing but concentration moles per meter cube. K nothing but Simon inverse only. So molar conductance, okay, molar conductance is equal to kappa into 1000 by molarity. Kappa into 1000 by molarity only. Clear? These are molar conductance only. Suppose I'm taking the some other one is look at here. If you go for next slide, you will get very clearly. So here, look at the, I want to calculate the molar conductance fixed area. I want conductivity. As the concentration decreases, conductivity decreases from strong and weak electrolyte. Suppose I want to take here this is I want to measure conductance only. Here the device used to measure conductance only. Because the how much volts are produced here, you will get clearly. Suppose if we take strong electrolyte, this value varies. Weak electrolyte as well is various. When I add more amount of water, this value will be various only. Clear? So what happens here? Specific conductance value. This is very important. Specific conductivity decreases with increasing severity, decreasing concentration. Okay, specific conductivity decreases with decreasing concentration. Specific conductivity increases with increasing the concentration. So molar conductivity, molar conductivity increases as the concentration decreases. Look at here, just consider that is depend upon the molar conductivity. Look at there, one formula is there. You can remember this one is molar conductivity. Represent molar conductivity is lambda m. Molar conductivity is equal to kappa into volume, K into volume. So when you decrease the concentration, this value decreases, but total value, this product value is increases only. That point don't remember because somewhat tricky, but you have to remember only. So next one is go for the next slide. You'll get a very clear idea. Okay. Look at it, just look at limiting molar conductivity only. If I decrease the concentration, I want to measure the conductivity at infinite dilation. How much concentration? 0. You want to measure the conductance, but limiting molar conductance only. Limiting molar conductivity is the conductance of solution of its electrolyte infinite dilation, approach 0. Concentration you cannot be seen like that. Called limiting molar conductance only. Look at here the limiting molar conductance of the weak electrolyte, strong electrolyte they have measured. This is very important. So limiting molar conductivity of the strong electrolyte, weak electrolyte they have taken. Look at here, if you take strong electrolyte, the graph will be like that one. It will come straight only. Okay, if you take the limiting molar conductivity, the graph will come straight. What happens here? If the concentration decreases, the limiting molar conductivity at one point is become 0 only. If you take the KCl value, if you take magnesium sulfate, the value will come like that one. Okay, this one only. For suppose here this value is there. If I take some other color, you will get very clearly. If I take the some other, okay. Look at it. Suppose if I draw for taking weak electrolyte is there, no? The molar conductivity value. If you take the weak electrolyte, okay, no? Sorry. If you take a weak electrode, the molar conductivity value is there, no? It will be like that one. Okay, no? This value. So look at here, in this area is then will touch the one point is strong electrolyte, the conductivity value will be equal to 0. But for weak electrolyte is there, no, that value is never be equal to 0. How can we measure? If they never be equal to 0, how can you calculate the molar conductivity? Means we cannot calculate direct method, we can use the indirect method only. I'll give one small example. It's called kohlausch law. Called as the kohlausch law. Kohlausch law. Okay, I'm starting to calculate kohlausch law. For suppose I want to calculate the conductance of the acetic acid. Look at the acetic acid. I want to take the acetic acid. CH3COH. Okay, COOH. How can I calculate it? By using indirect method, I said no. Suppose I am taking the salts of this acid. Okay, what is salt here? Sodium acetate. CH3COONA. COONA only. Salt on is strong electrolyte. I will take the here HCl. So what happened here? When I add together, when I add conductance of these two, minus of NaCl. Understand here? What happens minus of NaCl if you do? What is the Na will be cancelled. Cl will be cancelled. What will get the sodium acetic acid? Listen to kohlausch law. Kohlausch law has given idea to calculate the conductance of the weak electrolyte only by using of this method only. So the molar conductivity value is given here. They given some other here. Get clear. Graph is there here. So that value, look at the value becomes at one point become to 0 only. So molar conductivity is calculated by the molar conductivity infinite dilution minus into K kohlausch law constant into root of the C concentration only. Clear? The kohlausch law, this K value depend upon nature of the electrolyte. Nature of the electrolyte, charge of the electrolyte you can see easily. Suppose if I take the NaCl, how much charge is there? +1. So 1 into 1. How much charge is there? Calcium +2. 2 will come. Here 1 will come. Clear? This K value depend upon the nature of the salt or electrolyte only. Limiting molar conductivity is very, very important. You can kohlausch law only. The law is independent of migration. What is the limiting molar conductivity? What is said here? For suppose if I take the KCl. Suppose if I take the KCl. KCl if I take here, what happens here? KCl, the ions are very close. Look at there here. If I take the KCl. More amount of concentration. More concentration is there now. Potassium ion, chlorine ions are very close. They attract to each other. They will conduct electricity very less. If I go for dilution, what happened there here? K plus ion and Cl minus ion move away from each other. Long distance is there no. They never attract each other. They never repel in each other. So what happened here? The conduct depend upon each individual ion is there. The conduct depend upon each individual ion. Okay, that's nothing but a kohlausch law. If the Y and Z value is nothing but a coefficient value, 1 only. If you take the magnesium chloride, MgCl2, what will get MgCl2? Here 2 will come. Z value is equal to 2 will come. Here is 1 will come. Clear is there no? This is nothing but a kohlausch law. What is given here, the limiting molar conductivity can be represented as sum of the individual ion contribution of the ions as a cation and the electrolyte only. That's why only. Okay, what happened? He said one point very, very important for weak electrolyte is there no? When increase the concentration, the number of ions dissociation will be increases, conductivity also will be increases only. That's called as a here kohlausch law, very, very important kohlausch for a board examination. So here this formula. Look at the weak electrolyte. You can take a weak electrolyte there no? The molar conductivity of the weak electrolyte depend upon the generally on the concentration only. More less concentration is there no? Its conductivity will be more. Why more conductivity is coming means more ions will be dissociate only. Weak electrode having low degree of dissociation at high concentration. Degree of dissociation already discussed. Alpha value is very less for high concentration. When dilution increases, alpha value increases, dissociation increases, conductivity increase only. This one is given for weak electrolyte only. If you extrapolate in the graph between the molar conductivity, concentration to see, the graph will go like that only. It's never be equal to 0. So why this happen means no? At infinite dilution, the electrolyte dissociate completely, but the concentration conductivity is so low that cannot be measured directly. So by using of indirect method, can be calculated. Okay, here degree of dissociation alpha is equal to molar conductivity by molar conductivity infinite dilution. How will you get the molar conductivity value is going to dissociation constant Ka only no. So C alpha square by 1 minus alpha. I discuss here in the chemical equilibrium. This topic is there now. We'll discuss later. Okay, thank you students.